Hi, welcome to my video on graphing sine and cos equation using the starting point, increment changes, and amplitude. We've graphed the sine and cos function with the mapping rule. Now we're going to take graphing it from the point of view of the starting point, increment changes, and asymptotes. Opening from the starting point. We have an equation, y equals a sine b theta minus h plus k. So this is the equation. So if sine is positive, so that means we have a in this equation. A is 1, the b is 1, h is 0, and k is 0. So if h is 0 and k is 0, so the starting point is 0, 0. Right here. We graphed this before, again, based on the table of values of sine, but I'm doing it now from another point of view. So if we have a period is 360 divided by b, so it's 360 divided by b is 1, because there's 1 right here. That means the period is 360. So if you take the increment changes, I'm going to call the increment as INC, is P divided by increment changes is P divided by 4, because it's in 4 parts. P divided by 4. So 360 divided by 4, we have a 90. And that means that when we start with 0, which is what we have here, 0, 0, we add 90 on, and we add 90 again, we get a 180. We add 90, we get 270, and we add 90, we get 360. So that means we're here at 0, 90, 180, 270, 360. And the increment changes, the A is 1, so the A is 1, so the sine will leave here and go, the sine goes up from the starting point, so it goes up 1, it goes up 1 to the 90, so we got to mark that. So we got a 90, we go up 1, we got 180, we go down 1, we got 270, we go down 1 again, and we got 360, we go up 1. So we go up 1, down 1, down 1, up 1. So it's the increment changes are plus 1, minus 1, minus 1, plus 1. Because the sign goes up first, then down, and down again, and then up. So this is true also. The starting point for this equation, which has a negative sine theta, is still 0, 0, and the period is still 360, and the increment changes still the same. The increment changes are going to be 90, and it's still going to be 0, 90, 180, 270, 360, just like these. But when the sign is negative, it goes down. So if we leave here and go to the 90, we'll go down 1. And then it leaves 90 to go to 180, it goes up 1. And when it leaves 90 to go to, when it leaves 180 and go to 270, it goes up 1 again. And then it comes down 1. So the increment changes here is minus 1, plus 1, plus 1, minus 1. And this is true for all sine equations which has a negative. They'll go down, up, up, down. If it's positive, it goes up, down, down, up. And what about cos? Well, cos, again, the equation is still the same. The starting point is 0, 0, because h is 0 and k is 0. And the period is still 360. The increment change is still the same, 90 degrees. So it goes 0, 90, 180, 270, 360 still. But the cos starts right here. The cos starts at, the cos, I said 0, 0. The cos starts at 0, 1. My mistake. 0, 1. Why? Because when I put a 0 in for cos, the cos of 0 is a 1. Sorry for that. So sine starts 0, 0, 0, 0. Cos starts at 0, 1. And the cos goes, again, the increment changes. The cos goes down 1. Then it goes down 1 again. And then it goes up 1 and up 1. So the cos goes minus 1, minus 1, plus 1, plus 1 as the increment changes. And let's look at when cos is negative, y equals negative sine theta. Again, when you put 0 in, we got a 0 for h, and the k is minus 1. Minus 1. We start right here. 0 minus 1. So put 0 in, the cos of 0 is negative 1. So the cos is positive, it'll go down, down, up, up. So when cos is negative, it will start down here, it will go up, it will go up, up, down, down. Just make that little bend right there look okay. So the period is 360. The increment changes is still 90, but the cos, if it's negative, it's from the starting point, it will go up 1, up 1, down 1, down 1. So this is based on when the starting points are right on the y-axis. So what we're going to do now is graph some equations when the starting points are different and when the amplitudes are different, etc., etc., etc. Let's look at some of these equations. We're going to graph each. We have an equation that y equals 3 sine theta minus, or theta plus 90 degrees plus 1. So A is 3, B is 1, H is negative 90, and K is plus 1 or 1. So the starting point is H comma K. So the starting point is the minus 90. And if you put a minus 90 in here, you will get just minus 90 give you 0. The sine of 0 is 0. So you get 3 times 0 is 0, so you get a 1. So that's the H and the K when you have a sine. And now let's look at the increment changes. So the graph is starting off at negative 90 and a 1. At negative 90 is right here and 1. So that's the starting point. So let's look at the increment changes. The period is 360 divided by B. So that's 360 degrees divided B is 1. B is 1 right here. So the period is 360. And the increment changes. The increment changes is the period divided by 4. So the increment changes are 90. So we're starting with a negative 90. And we add on 90. So negative 90 add on 90 is 0. Add on 90. Add on 90. And add on 90. So as we do these are the, this is negative 90, this is 0, that's 90, that's 180, and that's 270. And the amplitude is A, the amplitude is 3. And because it's a sine, the sign is positive, it's going up. So the shape starts, and the sign forms a sideways S, but it's going up first. So notice it goes up, down, down, up. So that means the amplitude numbers are, the amplitude is 3, so it'll be a plus 3, minus 3, minus 3, and a plus 3. Plus 3, minus 3, plus 3. So as I go from to the right here, I leave here, and it says plus 3. So leave 1 at 0 and go to 3. And then it leaves and goes a minus 3, comes down to here, it comes down to a minus 3 again. 1, 2, 3. So there it is, right there. And there's a plus 3. So plus 3 right here. 1, 2, 3. So as I go across, it goes, notice it went up 3, down 3. Oh, didn't go through there. Down 3 and up 3. So there's the graph. And it continues on in that pattern to the left and to the right. Okay, let's do another one, hopefully. Again, you can graph them using the mapping rule with a basic table of 0, 91, 82, 73, 60, and get the mapping rule and sub in. But we're doing it with the starting point, increment change, amplitude, etc., to show you a different point of view. So this equation, A is negative 2, B is 3, B is 3, H is positive 60, and make it a K, K is negative 4. So the starting point is H comma K for sine. So H is 60. Opposite of negative 60 is 60. K is negative 4. And again, if you take the opposite of negative 60, which is 60, put 60 here, you get a 0. 3 times 0 is 0. The sine of 0 is 0. Negative 2 times 0 is 0. So we get negative 4. So there's the starting point. So the starting point is at 60 and negative 4. So if let's look at what the increment changes are going to be. So P is equal to 360 divided by B. So it's 360. B is 3 right here, 3. So the period is 120. So the increment changes. The increment changes is the period divided by 4. So it's 120 degrees divided by 4. So we're going to the right 30. So that means we got to have these markings in 30. So if we got the markings in 30, I can put a negative 30 here. And then that's 30 and 60, 90, 120, 180, 210. So we have to start at 60 and a negative 4. So there's 60, negative 4. 1, 2, 3. There's 60, negative 4. Okay, let's continue. We know what they have marked off and add on 30 each time. The amplitude is 2. The amplitude is 2. The amplitude is never negative or positive. The amplitude is the absolute value of negative 2 is 2. And sine is negative. Sine is going down. So the shape is, starting on the sinusoidal axis, it's down, up, up, down. So the amplitude is 2. So it's going down 2. It's going up 2. It's going up 2. And then it's going down 2. So as I move from the starting point, I will move the increments that I have marked off here. And I will go right here. I'm at 60. So it goes down 2 to the 90. So it's down 2. It's right here. I'm just doing an estimate. And then to 120, it goes up 2, back to the middle. And then at 180, it goes up 2 again. So it goes to here. And at 210, I got, oh, look what I got. I just noticed it. I always make those little errors. 120 plus 30 is 150 plus 180. So 150 and 180 is down 2 again, so it's here. Again, notice, down 2, up 2, up 2, down 2. And again, that's just part of it. We can draw this as it was going on. Again, notice the amplitude and how it's moving. A sine graph, if it was negative, will go down, up, up, down. If it's positive, it'll go reverse. It'll go up, down, down, up. Okay, let's look at another equation, but this one is in terms of cos. And again, let's look at what A is. A is 4, B is 2, H is pi over 2, this time is in radians, and K is negative 1. But the starting point for cos is H, and it's an A plus K. So H is pi over 2, and A is 4 plus K is negative 1. Make sure that equals negative 1, so it's negative 1. So it's, the point is pi over 2 and 3. Pi over 2 and 3. So that means, let's see what we're going to mark it off in. We know what the starting point, pi over 2 is a 90, and 3. Let's see what the increment changes are. So this time P is equal to 2 pi over B because it's in radians. So it's 2 pi. B is 2. So 2 pi divided by 2 is pi. So the increment changes is the period divided by 4. So pi divided by 4 is the increment changes. So when we start at pi over 2, so, and we're going with increment changes of 4. So this is, that's negative pi. So this is negative pi over 2. This is negative pi over 4. This is negative 3 pi over 4, because we're thinking about pi over 4 as being a 45. So 180, 90, 45, and that's 135. So we have a increment changes are pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. And 4 pi over 4 is pi. And this one right here is 5 pi over 4. So, the starting, okay, before we do that, we have radians. The amplitude is A, so the amplitude is 4. And cos is positive 4, so that means cos is going to go, when sine is positive, it goes up. When cos is positive, it goes down. It's just the opposite. So the shape is at its max. It goes down, down, up, up. So it's a minus, minus, positive, positive. So the numbers are going to be minus 4, minus 4, minus, minus, and then plus 4, plus 4. Because cos goes down, 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 up, up. So let's start at pi over 2, 3. Pi over 2 and 3 is right here. Now we got to see, we got to know. Pi over 2 gives us a 3, which is right here. Okay. Now we go, it comes down 4. So we go down 4 to the next one. So down 4. 1, 2, 3, 4 is right here. And it goes to pi. So it goes down 4 more. 1, 2, 3, 4. So it's right here at pi. And now it goes up 4. 1, 2, 3, 4 to 5 pi over 4. And I need this one, 5 pi over 4. That's 6 pi over 4, which is 3 pi over 2. So it's gone to here. So we go up 4 more. 1, 2, 3, 4. There it is. Notice we start at the max. It goes to sinusoidal in the middle, goes to the min, goes to the middle, goes to the max. So the curve is doing this. And it continues on in the same pattern, as you can see. Okay, so notice that cos is positive, is going down, down, up, up. Now we have a cos graph, which is a negative one. But before we do that, let's pick out A is negative a half, B is 1/4, and H is negative pi, and make that a pi, and K is 2. So the starting point is H, A plus K, and H is negative pi. Mark A. A is 1/2. Add on, negative 1/2, got to be careful. A is negative 1/2, add on 2. So the point becomes negative pi, and a half add on 2 is 1.5. So before we plot that, let's see what the increment changes are going to be. The increment changes, P equals, again is in radians, so it's going to be 2 pi divided by B. So it's 2 pi divided by B is 1/4. So that's 2 pi times 1/4, 4/1. So the period is going to be 8 pi. So the increment changes is the period divided by 4. So it's 8 pi divided by 4. So the increment changes are 2 pi, starting off at pi. So starting off at, negative pi. You got to be careful. So there's negative. So these are all pi's going up by. So this is negative pi. That's pi. 2 pi. That's 3 pi. That's 4 pi. 5 pi. 6 pi. 7 pi. 8 pi. That's 9 pi. So that's 2 pi. That's 4 pi. That's 6 pi. Oops, make that pi's now. So the amplitude is a half. Amplitude is positive. And when cos is negative, when sine is negative, it goes down. When cos is negative, it goes up. So it's up. I always know what sine is. Sine positive goes up. Sine negative goes down. And I say cos is the reverse, opposite. So sine is positive going up, cos is positive, it goes down. If sine is negative, it goes down. When cos is negative, it's the reverse is up. So the shape is, it's going up. So it's does this. It goes up, up, down, down from the starting point. So the starting point is negative pi 1.5. So there's 1. So there's negative pi 1.5. So when it goes, it has to go to, so when we add on the increments, so now we have the increments of a negative pi. First one, we add on 2 pi, so that's pi. Then we add on 2 pi, we got 3 pi. And then we got 5 pi, and then 7 pi. So we're starting with a negative pi, adding on 2 pi each time. There it is. So here, 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 there. And the increment change is, it's going up. So it's a plus a half, up again, plus a half. And it's going down, minus a half, minus a half. So here we go. Start here, and we go up a half. So that means you got to go to pi. So we'll go right to here, move over, and we got to go down a half. It's got to go to 3 pi. Right here, right in the middle. And now it's got to go, so we went up, up. Oh, it didn't go up. I didn't go up. I had to go up too. I should have went plus a half. Right now plus a half again, so I should have gone right there, and then it comes down a half, so it goes down a half to right here, and it comes down a half again to right here. So what it's doing, there it is, stretched right out. And just use my whitener for a second. I apologize for that. I just made a mistake, but I don't want to leave that dot in the middle there. There it is, gone. And so notice, as we take the starting negative pi and add on to 2 pi, we get these. So there they are at negative pi, pi, 3 pi, 5 pi, 7 pi. So we leave and go up a half. We go up a half again. We go down a half, and we go down a half. So there's the graph. And that continues on here and here. So hopefully that makes sense, because you need to understand what this is going on here when we set up some word problems, which is one of the last videos, not the last, but one of the last videos we're going to do not end off a word problem. Word problems is second to last set of videos. But you need to know what I'm doing here to understand that. And if you like what I'm doing, click the like button, click the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.